This video is doing a brief introduction to using standard normal distribution table. I want to start with z-score. When x is distributed by a normal distribution with mean mu and standard deviation sigma, for any x1, you can find the z-score z equal to x1 minus mu divided by sigma. And why is that good? Because then we basically, according to what we said in class, I can use the normal distribution n of 1 and 0 to basically find the probabilities for z, which gives me probabilities for x1. Now, how do I find the probability for a standard normal distribution n of 1 and 0? And let's take a look at this. Here you can see it says z right there. And then you see that there are values on the left side of the table, and then values on top of the table. How to read this is like this. If I want to look at z-score, let's say minus 3.6, then I look at minus 3.6 and 0, 0 right there. If I want to look at z-score, let's say this is z1, this is z2, minus 3.68. Then I look at minus 3.6 and then x. So that's the point. And so now, every time you look at these values, it gives you the probability of z, capital Z being less than, let's say, z2 in this case. So that is 0.0012. And looking at the picture, this is the normal distribution. This is the z-score. And the probability that is given in the table is that n. If you basically have a positive value, that was the negative value right there you found. This is the probability. If you have a positive value, you can find the probability of z bigger than that positive value, the positive z-score, which is the same as phi of minus z1. And then basically subtract from, if you want to find the phi of z1, you subtract from 1. A little reminder, phi of little z is just the CDF of normal distribution. Now let's start doing this problem. So the normal distribution is with mu 100 and standard deviation 15. I use the standard normal table to compute all these values. And so first one, it says find the z-score for x equal to 82. And so how do I find the z-score? So z-score for this case is going to be equal to 82, which is the value of x, minus mu, which is 100, divided by 6. This is going to be equal to negative 1.2. Now the next part is saying that compute P of x less than 82. This is equal to P of z less than negative 1.2. So let's go back to our table. I want to mention this. This is also equal to phi of negative 1.2. So now let's go back to the table. Negative 1.2. It's right there, and it's sort of a round number. So this is the probability that we have. Let's write it out. So that is 0.11504. Now for the next part, it says find the z-score for x equal to 113. Again, the z-score in this case is 113 minus 100 divided by 15. And that is approximately 0.867. Now the next part is saying that to find the probability of x being less than 113, which is the probability of z being less than 0.867. We know that we only have z-score, negative z-scores. So I'm going to compute 1 minus phi of negative 0.867. And so let's go back. Negative 0. That's a negative 0.8. Look up, and I need 6, 7. I have the option 6 or 7. I think my number is closer to 7. I could also, and if you feel like the number is close to both values, if you have a third digit, decimal digit, and they're close to both values, you can also find the average. But right now I don't need to, so the third column from the left should give me the answer, which is right there. 1 minus 0.192. Which is, again, this is approximately, which would be the value 0.80785. Next part is asking find the value a such that p of x less than equal to a is equal to 0.7. So the best way to do this is basically use to find the z-score associated with 0.7. That is, find the z-score by taking the inverse CDF of 0.7. This is saying that the CDF is equal to 0.07. Now you are, basically the CDF is equal to 0.07, means that CDF of the z-score is going to be equal to 0.7. So let's go back in here. Now I have to look at all the probabilities and find the value that I'm interested in. So they are increasing over here, but when I'm looking, the 0.7 is not in this table. And how do I fix this? This seems like the value that a value of A is larger than mean. Therefore, I should probably look at this value instead. So I'm going to look at Z equal to phi inverse of 1 minus 0.7. Why? Because this is going to give me that little tail value right here. And then I can compute that would be the same thing as that. And then I subtract, basically subtract from, if I subtract from 1, I get the value that I want. You have to remember this z value is going to be a negative value, but the z value that you want is a positive value. So I'm going to look at z equal to phi inverse of 0.3. Okay, so 0.3 is, where is it the closest? I can see that this value is the closest that I can get. And that's minus 1.8, and that's the last column, the one before the last column. So it's going to be, this z value is minus 1.88. So this is minus 1.88. And again, because the z value that I'm interested in is the other one, the one that is a positive value. I computed this to be 0.3, so this is going to be 0.3, and therefore everything else right here is 0.7. So multiply by negative sign, let's call this Z2 instead of Z. So the actual Z is going to be equal to 1.88. Now, how do I find A? Remember, this is the Z-score, so it's 1.88 equal to A minus mu divided by 15. So A is going to be equal to 15 times 1.88 plus 100.